Prospects for the use of a vibratory jaw crusher with an inclined crushing chamber for processing of brittle materials. In nature, there are a large number of brittle materials, but it is difficult to obtain a fine-grained and powder product from them. This is due to the discrepancy between the physical and mechanical properties of the material and the method of applying force to it. In particular, the widely used minerals quartzite, basalt, marble, etc., have a high compressive strength, about 400 megapascals, and low resistance to impact loads. At the same time, a significant percentage of the equipment used for their disintegration is made up of jaw, cone and roller crushes, in which the destruction of the material is carried out by compression, and the low degree of crushing predetermines the multi-stage nature of the technological process. The use of impact crushes, hammer and rotary, is not rational, since their scope is limited by the strength factor, the value of which is often lower than the strength factor of the rock intended for disintegration. At present, vibratory jaw crushers are used in industry, which have a clearly defined impact nature of the load applied to the crushed material, which have the advantages of jaw and impact crushes. The purpose of the work is to evaluate the effectiveness of using vibratory jaw crushers for processing brittle materials to obtain a fine-grained and powder commercial product. The standard for determining the effectiveness of the use of crushing and grinding equipment is glass, which has high compressive strength and low impact resistance, which is destroyed by mechanical action without noticeable plastic deformation and belongs to ideally brittle materials along with diamond and quartz of all types of glass. Glass containers with standardized mechanical properties and geometric dimensions are accepted as the starting material. At the same time, interest in obtaining glass powder is currently growing in the world. This problem is relevant, as it is associated with a wide range of properties that make simple and special glass powders a universal material. Powder production is a complex and energy-intensive process, which includes all stages of glass production. The raw materials for glass production are quartz low iron sands, soda ash, limestone, dolomite and others that require preliminary enrichment, washing, drying, grinding. The resulting glass mass is again subjected to crushing, grinding, separation, which creates a high cost of production. At the same time, hundreds of thousands of tons of glass waste are generated annually, but only an insignificant part of them passes into secondary resources. Recycling glass allows you to save raw materials and save huge areas of land, which, otherwise, should turn into environmentally hazardous landfills. Based on this, the problem of assessing the effectiveness of using vibratory jaw crushers for processing glass waste to obtain glass crumb is also considered. Depending on the composition, glass chips and powders can meet a variety of requirements and be used as additives in the production of fiberglass, foam glass, glass concrete and other materials. A physical picture of the destruction of the material by a single impact, and the main dynamic characteristics of the crusher were determined on the developed laboratory installation with a horizontal pendulum impact tester. The installation includes a pendulum, at the free end of which there is a shock assembly. The fastening of the impactor allows you to set a different profile of the working surface that interacts with the glass. The height of lifting, dropping, of the impactor is determined by the measuring system. The signal from which passes through the vibration measuring equipment of 6 to 6TN. The USB oscilloscope and registers the height of the dropping of the load on the laptop screen. This system also makes it possible to trace the nature of the interaction of the impactor with the material under study. For the same purpose, an acceleration sensor is attached to the shock assembly, which records changes in acceleration in the vertical plane. The initial application of the load was simulated with a different method of feeding a bottle into an inclined crushing chamber of a vibratory jaw crusher. As an example, the results of the impact of a single impact of a flat striker on bottles for sparkling wines are given. The mass of the impactor is 5 kilograms. The drop height is 0.7 meters. When a bottle is fed into the crushing chamber with the bottom towards the discharge window, the bottle is destroyed by a single blow. However, more than 50% of glass breakage has convex shapes, which reduce the fill factor of the transport container. When a bottle was fed into the crushing chamber with its neck in the direction of the discharge window, a product with a size of more than 50 millimeters was mainly formed with a crushed neck and a whole bottom. The bottle can be loaded into the crushing chamber in a position where the longitudinal axes of symmetry of the bottle and the chamber are perpendicular, when exposed to a cylindrical surface by a point load. The neck and bottom are not subjected to destruction, with sufficient destruction of the cylinder. The preferred result is obtained when the surface of the bottle interacts with a distributed load Q. The result obtained shows the sufficiency of one impact for the effective destruction of a brittle material with internal cavities, which predetermines the need to create small-sized crushing plants. Grinding was carried out on a laboratory sample of a vibratory jaw crusher, which includes a passive, lower, crushing jaw 1 and an active jaw 3. Vibrations of the jaws are generated by a two-shaft inertial vibration exciter 4. The destruction of the material occurs in the crushing chamber formed by the working surfaces of the passive 1 and active jaws 2. Crushing was carried out on bottles with a cylinder diameter of 90 millimeters, identical to those studied on a pendulum impact tester, based on the fact that the width of the crushing chamber of the laboratory sample is less than the height of the bottle. Its loading with the bottom in the direction of the discharge window. At the first contact of the bottle with the working surface of the jaw, the process of destruction of the bottle corresponded to the destruction on the impact tester. A high-quality mass of a flat shape was obtained to fill the transport container. However, a feature of the crusher is the possibility of producing marketable products. Subsequently, the resulting flat material moved in the crushing chamber to the discharge window, receiving a high-frequency impact. The graphical dependence shows 100% of the output used in the production of coarsely ground material, 50% of finely ground and 40% of powder. All narrow classes of material size, obtained by single crushing of cullets, are used in decorative products. Powders 100 microns as additives to lubricants. Modifying additives to adhesives. All fractions less than 5 mm are used in various grades of concrete, according to the purpose of the work. The studies carried out on the example of the destruction of glass containers substantiated the efficiency of crushing brittle materials in a vibratory jaw crusher with an inclined crushing chamber. Feeding a cylindrical feedstock with a diameter of 90 mm into the crusher and obtaining a fine-grained product shows the prospects for creating a small-sized vibratory jaw crusher with the implementation of medium fine crushing and grinding in it, which will significantly reduce the number of units in the production process chain, reduce their cost and expand the range of products obtained, fine-grained and powder materials. Thank you for attention.